All right. Sorry to be so weird. All right, let's go. Let's hop over to exorcism. Exorcism. Okay. Let's see the Reason ML. So I think I had some trouble or whatever with the Reason ML just getting it installed and working. I think it should probably be no problem now because OCaml is installed and working, right? We knocked out one of, or I knocked out one of the OCaml problems, I think. I think. Hold on, let me look. Where's OCaml? Okay, yeah, I knocked something out in OCaml. What was it? It was Minesweeper. All right. So now that that's knocked out, let's try for Reason ML. Okay. So let's find the install guide here. Looks like I did knock out the Hello World actually. Interesting, interesting. So what was the actual trouble that I had? I don't know. I don't know. Let's go to the anagram and see what the trouble actually was here. Reason ML. Okay, let me look at the Hello World. So the Hello World works, I guess. What happens if I do this? So that's fine, right? All right. Interesting. So now let's try the anagram. And if I do test on this one, what happens? No tests found. Doesn't seem right. So if I go into tests, okay, so there are tests here supposedly. Okay, let's see what the help says. So we need to do npm I. Did we do that one for this one? Looks okay. Open two shells, and in the first start the build process. Okay, let's see what we got here. Start. Found a bug. Okay, so Reason ML is like similar-ish to OCaml, right? Which is similar-ish to F# from what I understand. So maybe it'll be easier if I do anagram first in F#, maybe? Right, so here are all the languages that are available. So what if I were to do it in C#, and then F#, and then Reason ML, right? Like working my way up to it, right? Because C# is part of the .NET family, same as F#, but C# is more of a structured programming language with strong, like, OOP characteristics, right? Okay, so let's grab this. Right, so if we do it in C#, then we can probably figure it out in F# using maybe some of the same .NET facilities, or maybe not. Let's just see. C#, there it is, C# anagram. Okay, let's take a look. So if we try running test on this one, what will happen here? .NET test, okay. I've got my handy dandy energy drink. I don't know if that's readable, but this one is the does it say unsweetened? I think it's unsweetened. It should be unsweetened because the ingredients list is just carbonated water, natural organic flavor, Organic caffeine. So it's just fizzy water. Caffeinated fizzy water. As long as it's unsweetened, I figure that's good enough for me. So, okay, so we ran the test and that's fine, right? Okay. So then what was this anagram even about? Are we getting two strings and checking if they're anagrams? Let's see, what's it say? In the README, it explains that given a target word and a set of candidate words to find the subset of the candidate that are anagrams of the target. Okay. So this sounds like a good one. So if we go into the anagram CS file, here's what I've got. I've got anagram, and I've got find anagrams, right? Okay. So in this constructor, we have a base word, so I'm just going to say string base word. That's kind of oopish, right? I guess something like that. I think it's fine. Where's my semicolon? Okay, so now we are gonna get a array, I guess, of potential matches, and we want to filter these. And so I guess we're gonna presumably use link, right? So using system link, C# using link. So link is quite a powerful API, but we just want to grab it for the simple filtering, right? Using system collections generic, using link. Yeah, let's totally do that. Okay, so now if we're going to try to find some anagrams, then we're going to take, I guess we're going to say bool is anagram, right? Okay, so now, do we have to do counts? What's the, in system collections generic, is that where the dict is in C#? I think it is, right? I think it's called a dictionary, actually. C# system collections generic dictionary. That's where it is, I think, right? Dictionary key value. So we're gonna say dictionary char int uint count so we want to count the chars in a string, right? So we're gonna say for int I equals 0, I less than s length, I plus plus, I think it's like this, something like this. And then we say if, or no, we have to initialize our dictionary first, I guess, right? So we'll say var result equals new dictionary char uint, right? Okay, so now if result, do I have LSP for this? Hold on. I don't seem to have any IntelliSense working right now. Vim C# LSP. Roslyn based. Okay, let's try this. When I did C Sharp, I always used Microsoft Visual Studio, which had superb IntelliSense, right? And it's a crutch. I know it's a crutch. Obviously, it's a crutch. Okay, you can invoke with this command. Okay, so now what about using this in Vim? Wait, is Vim here? Okay, so we want to say what? A plugin for, let's take a look. Mm, I don't think I want to do all that. Omnisharp Vim. This sounds like a winner. I just want... I'm always this way. I just want to get something up and running quickly. And why not? I'm doing 144 exorcism assignments for the year in many of these different languages, right? So of course, I just want to get something up quickly. Okay, let's try this. But also, I'm just dumb, right? Like, but we've established this. It doesn't really matter. All right, so Vim. Okay, so this is sharp. Okay. All right, do we think that's going to help? Yes. Hit me with it. The OmniSharp server, baby. What is this? Okay. So with any luck, are we going to get some IntelliSense? I could really use some. It's a dictionary. Has. I'm still not seeing anything. Okay, I'm just going to look it up then. Okay, so C#, yeah, dictionary. And I think it's has. Is it has? I just want to confirm that it's has. It might not be has. Wait, where is it? Remove, add, keys, try get, methods. Isn't it has? I guess not. Contains key, okay. Okay, so then we do add. No, we do Okay, so we can't add if it's already in there, but we just want to update, right? Shoot. Gets or sets? Okay. Should be fine. Okay, so result SI plus plus, right? That's all I really want. Okay. Else result SI equals 1, right? Man, I was really hoping for some LSP to work. All right. I mean, I know it'll work if I spend a little time to get it to work, or at least I suspect. I strongly suspect. Not gonna spend much time here though. Okay, so var base count. Oh, actually, we might as well just make a base count right at the start, right? So dictionary char uint base count. This base count equals count base word, right? We might as well, I guess. So var word count equals count word, right? And then we're gonna say we're gonna iterate through the keys. Okay, so we're gonna say result equals true, return result. We're going to say for var key. Oh, it's in C#, it's for each. For each var key in word count, right? If word count key not equal base count key, so we don't want to do that. Let's just return true. Okay. Return false here. If the key is not in there, is it gonna make an exception? Probably. Key not found, so we don't want that. So we're gonna say if not base count contains key, return false. Okay. So we also have to say at the start, so if word equals base word, return false. Okay. For each var key in base count. So this seems pretty inefficient, obviously. If word count contains key, return false. If word count key not equal base count key, return false. All right. Yeah, and so then we're gonna say we're gonna filter C# link Filter array. Filter an array. We want to use link. Using link, so we're gonna set, so we get this input, and we say where, and we say to array. Amazing, amazing. So we're gonna say return potential matches where is anagram to array, right? So that's it, I believe. That match what they did here? I think so. Okay, let's see what happens when we run the test. I missed a bracket. 19. Is this why the LSP never worked? Because my syntax is so bad? Alright, any others? Not all code paths return a value. Yep, can't leave that out. Cannot convert from key value pair to char. Alright. Why is it key value pair? This is on 34. For, oh, so it's a key value pair. Gotcha, gotcha. Let me take a look at the key value pair. Because, I mean, that seems fine if it returns a key value pair. Key value pair, yeah. So I'm assuming it probably has a property for the key and a property for the value. Okay. So then, let's see. Contains key, key value key, sure. And then here, we want to say, let's see, we don't want this. We want key value value, right? And then here again, key is inaccessible due to its protection level. Darn. No, it's still inaccessible. Shoot. So parameter, the key returns key value pair, struct. Oh, is key with a big K? Oh, they're with big K and big V. Oh, shoot. Well, I don't know what that was. Okay, so big K, big V. Let's go, let's do it. Key value does not exist on 39. Oh, right. It passed 1, skipped 15. So now let's go into the tests. Okay, so we're going to remove the skip property, I guess, everywhere. Okay. Passed 11, failed 5. Oh, okay, okay. All right, so words other than themselves. Okay, so we had expected silent. Oh, I need to do 2 lower. I'm gonna have problems with, case. So we need to do, lowercase, basically. So in the count, we're gonna say var lower equals s dot to lower, C sharp string to lower. Okay, to lower. Okay, so then instead of using s, we're gonna use lower. Okay, so we had 5 fail. It should be fewer now, I believe. Let's see. Okay, so 2 failed. Good. So now what's this one? We had banana, and words are not anagrams of themselves, even if letter case is completely different. Okay. So that's here. So if word to lower equals base word to lower. Okay, let's submit. Okay, so that wasn't too bad. Actually, that was kind of bad. That took me a while. Oh, the robot has a suggestion. It says, as the find anagrams method only has a single statement, consider converting the method to an expression bodied method. Okay, let's do that. So public string. So for expression bodied, we want to say this, I believe. Is that how it is? Let's see what it says. Test. Okay, let's submit. That was a good suggestion from the robot there. Okay, so iteration 2 passed. Great, great. Let me look at it one more time to see if I want to refactor. Okay, so public class anagram, string base word, public dictionary base count. Sure. And then we use the count like this. I think this is fine. So is anagram. Yeah, okay. I'm gonna mark that as complete. Now let's try it in F sharp. All right. Okay, close all these. Because F sharp, from what I understand, the syntax should be quite close to Reason ML, right? We'll see. We'll see how it goes. Okay, so anagram. And let's try it now in F sharp. So now, of course, we know the syntax of F sharp is quite different from C sharp because, of course, we know that the C sharp syntax is inspired heavily by Java. Whereas the F sharp syntax is intended to be close to OCaml, from what I understand. So let's take a look. So we have let find anagrams, sources, target, fail with, you need to implement this function. Okay. So we're going to want to do 2 lower, but the thing is, because it's all .NET, like we should still be able to use the same .NET methods that we were using. I think. Okay, so we're gonna say if target to lower equals sources to lower. All right, then false, else true. All right, so that's, wait a minute. Look up on object of indeterminate type based on information prior to this program point. Okay, so we need to add a type annotation. Let me see how that looked in my other F# file. Like Bob. How did Bob look? So we put a type annotation, let response input string to string. Okay, so let's try something similar here. So I have sources. So we think this should be a array string, and target, this should be a string. Okay, so now obviously this kind of shows where I made the mistake. Also, like, is this, hold on. Is this supposed to be curried? It is, right? So do we have a colon here? No. No, I think it's different. It's not like Haskell, right? I mean, it's somewhat like Haskell. So obviously this is not what we want. Oh. Do we put list string? You think it's maybe like that? The pattern discriminator, incomplete. Shoot. Okay. Let me see if there's, so for Bob we put let response input colon string, and then we put colon string. Okay, now let me see. We also did yacht in F#. How did this one look? So we had type category die. So most of these we did without type annotations, but here we have list int, so that helps. So it should be list. So this is more like the familiar type syntax from C#, right? List string, target string, string. I guess they should be small, right? I don't know. So the pattern discriminator find anagrams is not defined. Okay, there we go. So now we don't do that. What we're going to do is we're going to try to filter, which it might, let's see. F# list filter. I think we just do, we don't do this. I think we just do list filter and then put is anagram, which we're going to define. Is anagram target weirdly enough, I feel like after these exercises, I feel like I'm more comfortable with the Haskell type syntax than the OCaml type syntax, but I guess that's natural because I've just done more with the Haskell type. The Haskell type syntax. Okay, so, and then just put sources. And then we need to say let is anagram, and we put a target in there, and then a word, equal, and then if target to lower equals word to lower, then false, else true. Okay, so now what's it say? So now we have to mention that these are strings. So this is a string, please. And this one is a string. Whoops. The type string does not support double equal. Okay, so I wrote it down yesterday. Learn to choose the correct equality operators. Still haven't learned it. Okay, so is it EQ? Okay, so F sharp equality operators. Let's take a look. Okay, so equals with a single equal. Maybe that's what we want then. Okay. Well, I've been floundering a bit, but hey, you know what? I think that's a start. So let's run test and see what it says. This value is not a function and cannot be applied. So I think we're talking about here when I did is anagram target. So my intention was for this to be like sort of curried or whatever, but I think that's not what we got because it's not Haskell. So, F sharp higher order function. Let's take a look. Wiki book? Sure, hit me with it. Okay, so higher order function. So we can pass a function to another function. And we can return a function from another function as well, right? So I think, yeah, we want a partial function. That's what we want, a partial function. So let add xy equal x plus y. Oh, okay, well, that is what I intended to do here. So is this going to be more explicit for me? Let's try it like that. So let is anagram, and I'm going to say equal, and I'm going to say fun target string. I want to say this part goes in parentheses. I'm not sure. And then I'm going to say skinny arrow, and I'm going to say fun word string skinny arrow, and then it's going to be this if, right? Okay, now what does it say? Unmatched. So the other parenthesis goes, I believe, here. And here. Is that crazy? Okay. Not a function and cannot be applied. Okay. So we're looking at tests 11. Let's take a look. So on 11, it says, find anagrams, candidates, diaper, should be empty. Okay. So which value is not a function and cannot be applied? It's not helping me very much. What value? What value? We can do F sharp on the REPL, right? F sharp REPL. Interactive mode. So you just do .NET FSI. Okay, so .NET FSI. Okay. So now let me help. Okay, so let's try hash quit. And so now let's put the file out here so we can see it. And .NET FSI. Okay, so now let's say let is anagram. Okay, so now can I say is anagram? And we're supposed to have two words, right? So I'm going to say hello, and I'm going to say goodbye. And I'm going to say double semicolon. True. Oh, okay, yeah, because they're not the same word. All right, so now let's say hello. Okay, so this is a function. Now let's try this next part. So I'm going to say list. I'm going to start with list map. I'm going to say is anagram hello. And now I'm going to try to make a list where I say hello, hello, goodbye, goodbye. False, false, true, true. Okay, so that part seems like what I expect. So now let's try filter. Yeah, I mean, it seems like what I expect. So what does it mean, not a function cannot be applied? Darn it. Okay, so now let's copy this. And I think we're about to find out what the problem is. Okay, so now I'm going to say find anagrams. Hello. Bye. All right. Not a function cannot be applied. Okay, great. So now we're going to say list filter. Okay, so I'm gonna rewrite it to look more similar to the other one. And hopefully that'll be okay. So find anagrams, I'm gonna say equals fun. We're gonna take sources, list string, and then I'm going to take fun, target, string, okay, now what's it say? Okay, great. So let's make this first one pass. So it was supposed to be a non-empty, and actual was hello world zombies pants. All right, so now let's do like the actual anagrams, I guess. So let's see. So we need to count the letters, right, like we did in C#. So I guess we're gonna say let count equal fun s string and then we're going to create a dictionary here, right? So F# dictionary. So we want to map an immutable dictionary of elements, right? We used this before, I believe. I mean, I clicked it before. Let's see. Was it in what was it in? Did we have it in yacht? There ended up being kind of a lot in yacht. Yeah, here we did a map empty, and we added, oh yeah, this is exactly what we want, right? Count. Oh, well in that case, I am just gonna copy that. Because that's pretty much exactly what I want for this one as well. Okay, so copy. Okay, so this one says, let count dice equal. All right, so we're not going to take dice this time. It's going to be S. Okay, so that part is right. The trouble is, I don't think we can use a string as a list necessarily. F# string to char list. We're always having to do this. Sequence to list. Great. So here we're going to say sequence to list S. Okay. So now when we do this, so if it's equal, then false. All right. So else is not going to be true. We're going to do a count. And we're going to compare these maps. Let can we do an equality comparison on one of these maps? Probably not, right? Okay, I need to take like a 5-minute break. Okay. Yeah, I'll be back 5 minutes. Hopefully. I might actually have to stop depending on what this is. Okay, back. Back. All right. So, ah, let's see what it is that we're doing here. Um, I gotta take a second to think. So we were about to try to compare the two maps, right? So we want to be sure that the map, so if they are anagrams, if they're genuinely anagrams, then we need to discover that these maps will identically match, right? So, let's just say AB, maybe. So now we've got to go, is it a fold thing? Where did the initial value go in the fold? Oh, the initial value was map empty. Okay, so we're gonna say, um, we're gonna say B. So A and B here are gonna be map I think. So now this is gonna be B contains, let's see, B contains key LM and like that. Okay. Unexpected keyword and. Okay, so let's look at F-sharp logical operators. So we want double and. Yeah? Okay, so we're trying to fold. I didn't close the function brace. Okay, so then we're going to say, let's see, type constraint, system collections generic char is not compatible with type char list. Oh, darn. Oh, darn. Huh. I would have thought that those would have been compatible, but let's see. So we want to fold the element should be a char, we think. Oh, interesting. So A keys we thought should give char list or not. Keys returns I collection key. Okay, so F sharp I collection to list. Can we do that? List of sequence. Okay, so we have some collection, then we cast to sequence, I guess. Okay, let's try like they did. So we're gonna take a dot keys. All right. Sequence cast, is that what they had? And then they had list of sequence. Expecting expression. Oh, expecting expression here. I'm just gonna put true for now. Amazing. Okay, let's shout that out. Okay, it was right here. Amazing. Okay, so cool. Okay, so then we're gonna say and list old. Okay, so now I'm gonna copy this. Copy this. Yeah. Okay, so now this time, this one will be A. This one will be B. Those can stay the same. And yeah, so what happens when we run the test? It says fail. Okay. Now, here we are gonna do maps equal. Oh, and the other thing is when we did the count, this should have been 2 lower. And S should be string. Yeah? Uh-oh. Uh-oh. Sequence to list. I think that might be mistaken. We'll see what it says when I try to run it. Okay, so then maps equal. And it's going to be count. Target. Count word. Okay. Now, I think it's going to complain. Okay, so successive arguments. This is on 9. Successive arguments should be separated by spaces or tupled, and arguments involving function or method applications should be parenthesized. Okay. I think that makes more sense, probably. So that's here. So this has to be, whoops, here. Type string, okay, string is not compatible with the type int sequence. The type char does not match the type int. Oh, why is this int? Is that what it was this whole time? It was supposed to be char. Okay, on 4, expression was expected to have type char, has type int char. Okay, so this one should be char as well. Okay, so we passed 1. Let's turn on the rest of the tests. Let's see what we've got, baby. Okay, so past 16, let's submit. Okay, so now the theory is that that what we just did here in F# should be close to what's needed in Reason ML because they're part of the same family, right? So Reason ML Wikipedia. So influenced by OCaml, JavaScript. And if we look at F# Wikipedia, this is influenced by C# Elm F* LiveScript. Oh, no. Influenced by, okay, so here's OCaml. So yeah, it's a member of the ML family, originated as a .NET framework implementation of a core of the programming language OCaml. All right, so now how close is that to what's described here? Syntax, extension, and toolchain for OCaml, right? So in short, I call them both OCaml variants, which supposedly means they should be similar. We're going to find out. Okay, so that says passed, no robot hint. Let's see if I want to look at any refactors, possibly. I might, because some of this seems very inconsistent, like I used sort of weird syntaxes just to try to get the thing to work. So now, let's try not doing that. So instead of doing this, let's say target string. All right, and let's not do this. Let's just say word string, and then let's just say equals, right? Okay, so that's much better. And then here as well, find anagrams. Let's get rid of this. Get rid of this. Get rid of these. And this, and just say equals. What is it? Okay, this refactoring is good. Now, do I even, so if, in a lot of cases, you don't necessarily need the type annotation. Can I get away without having a type annotation on this one? Whoops. Great. So much better without the type annotation. Now here, because I'm going to call to lower, I think it requires the type annotation. Let's come back to it. Do I need this? Okay, love it. So yeah, basically, I guess I'm just trying to reduce some of the noise that I have in the source code file. Which I think can be worthwhile. Okay, so now also, here, I believe we should be able to use pipe syntax instead, which I think is a little less noisy than using parentheses. Okay, whoops. Okay, so that's nice. I think I want to leave this maps equal alone, but it is kind of nasty. Actually, it's quite nasty. So, do we have a F# command line? Let's see, F# command line source code formatter. I feel like I was using something, wasn't I? Code formatting. Oh, interesting. So, the Phantomos. Yeah, okay, let's try that. .NET, yeah, let's install that. Okay, so now .NET .NET ZSH completions. Add this to the ZSH RC. Seems like a lot. Look how little fish has. Maybe I should be using fish. Probably, honestly, but let's just go with this for now. Alright, I'm just gonna try adding this right to the end. Let's see. Okay, so how do we, so I'm glad we have the completions, but how do we actually use this? So we install it here, and then we go here, and we end users, getting started. Okay. Okay. Let's see what we get. Input path is missing. Okay, so help. Formatted. Okay. Oh, man. Oh, man. Oh, man. Okay. Yeah, this maps equal looks very bad. The count looks questionable as well, honestly. So, I'm going to say let maps subset. We are going to take a map char int, b map char int, lm char equals, and then it's going to be basically this. Uh-oh. Given key was not present in the dictionary. I should be using git. I think we have to turn these around in this case. Okay. Let's format again. Better. That's actually so much better. Wow. Great. All right, so now when we do these, are these parentheses needed? I think they must be, right? Whoops. Okay, so they must be needed. Okay. Yeah, that maps equal looks much better with that one part of it pulled out. Okay, so now what about this count? So this one is going to take ack map char int lm char equals okay. So increment count is like this. Ah, yeah, that's much nicer. Much, much nicer. Okay, this part is a little weird. So let's say, let's just take that part out as well. So let list of keys, and that's going to take a map char int equals, and it's going to be a keys sequence cast list of sequence, right? And then here we will just say whoops. I think that's probably enough refactoring to satisfy me. Yeah, this is much, much better in my opinion, I think, than it was before. So let's resubmit. Okay, passed. No robot hints. Okay, so we'll mark that as complete. Now we're going to move over to Reason ML, baby. This is going to be great. So I'm going to put the F sharp. Where's my actual file? What the heck is all this? Oh, it's in source. Anagram RE, anagram REI. Okay, okay, cool. In F sharp, I didn't really see those interface files, but that's cool. So, so the RE file, oh, I've got a whole bunch of JavaScript in there, so that was my first attempt. It was nonsense, though. What's the interface file look like? It's just anagrams, string list, string. Okay, so great. So I'm gonna copy my F sharp file into here. Okay, so now let's open up our anagram file in the editor. Okay, so whatever I had before, I think I am just gonna delete it because it certainly wasn't working. Okay, so this is what the F# file looked like. So in theory, the Reason ML version is going to be pretty similar. So these two lower method calls, these come from .NET, so I would guess those probably don't work. But let's see what happens when we run test right now. Okay, so let's see what happens when we look at the help. All right, so here's what we're supposed to do. npm I. We did that already, but let's just hit it again. I think we're okay. Now we're supposed to npm start. It says we found a bug. There's been an error running reasons parser on a file. Syntax error. All right, so line 3, syntax error. Okay, fair enough. So I guess we probably don't use let. Let's see what we use. Okay, reason ML getting started. Reason ML getting started guide. Let's take a look. Okay, so we said let greeting equals person fat arrow. So do you think we need this fat arrow? Oh my gosh. Should we use the reason language server? It might help. Some of these help a lot, and others not so much. And it's a crutch, of course. Everybody knows it's a crutch, but whatever. I'm doing so many of these things over the year. I just want a crutch to get me through to the other side. And then if they do another challenge next year, I'll be more equipped to do it with less crutch, maybe. All right, so it says that's installed. That's good, I guess. All right, so is it gonna be able to give me any hints? It says BSB exe not found. Well, why would we look for an exe? I'm not on Windows. Well, that's pretty messed up, man. Pretty messed up. Okay, well... So it looks like we are wanting to use fat arrows. Let's look at let bindings. Let's look at basic structures. Let's look at functions. Okay. Oh, it was supposed to be equals. AB ac lm. Target word. Okay, it says the same thing as before. Oh, I don't think we can have that. All right, so now let's see. Okay, line 2, characters 7 through 10. So do we always switch? Oh no, we used if here. If... Okay, okay. Unclosed? Oh. Did I? This one looks closed. Which one's unclosed? I am gonna struggle, actually. I can see that. So, yes, it seems that ReasonML has a syntax that is some strange combination of something like OCaml with something like JavaScript. It doesn't look nearly as OCaml-like as I was kind of imagining, except, I mean, I say that, but the truth is I just don't really know OCaml. But, yeah, so my thought process now is to try some basic ones in ReasonML to sort of like dip my toes in. I'd really, really like to finish this ReasonML problem assignment before work today, but I don't know if that's going to happen. Okay, let's give it a shot. Is leap year int to bool? Okay. Right. So it's a simple one. Let's see. So we have to npm I. Holy crap. Then we npm start. And it's like, okay, hey, there's nothing in there. So Okay, so let is leap year equal n. Okay, so then in the functions, we're going to say if, yeah, let's say if n mod 4 equals 0. Actually, let's just start with n mod 4 equals 0. So I did a triple equals because some of this reminds me of JavaScript, but let's look at reason ML. I wrote it down yesterday. Learn to choose the correct equality operators. Equality operators. Let me see if my laundry is actually going. Hold on. It was not going, but I just started it in the dryer. I think I got it in there just barely early enough that I'll probably be able to get it out before work. Okay. So, look at that. It is in fact triple equals. That's crazy. Look at that. That is nuts. Okay. All right, so let's just start with that. Okay, so now npm start. Okay, so we don't have mod. Where are the reason ML arithmetic operators? Boolean numbers. Okay, so we have to use mod. Okay, so now it did something. So now we open up another one. And we go to... Okay, so now that we did npm start, we do npm test in the second shell. Okay, great. So now we're going to fix the other ones. So divisible by 100. So this is running. And what is this doing? So this is running. So it's basically a 3-shell situation. Time to add tmux to my list, right? Like with tmux, I guess this would be no big deal. So yeah, 1 shell to run the compiler, 1 to run the tester, and 1 to run the editor. It's fine, it's not a big deal. I'm just not accustomed to it. Uh-oh. Am I in the right place? BSJS. Oh my goodness gracious. What do they call that? Buckle script? Oh my. Okay, so we're gonna say nmod 400 equals 0, or Oops. Okay, so we save that. And now what does the test say? Oh, so, okay, so now it says passed. Okay, so that's fine. That's fine. So what we could do, like, if we were, like... And this would work better if I didn't have the text so huge. But we could make this smaller, right? And then we could make this one smaller. And just sort of move them into places. And maybe even make the editor smaller. I don't want the editor smaller, to be honest. But these could be small, like this. Yeah, I think I'm kind of okay with that. Then let me see. So I would put this one maybe somewhere by my head, or like right here. Can you kind of see it good? And then this one, did you notice how, oh, I like how the windows sort of snap together. And just snap that to the bottom. It's not terrible. Not terrible. So let's exorcism submit that. Okay, let's take a look. Okay. I'm gonna try one more and then go back to the one that I actually need to do. So we did leap. Let's take a look at... Oh, I don't like bomb. Is there one here that I haven't done before? I don't think I've done word count, have I? This is going to be pretty relevant to what we do in anagram. Oh, I haven't been opening that editor at all, for the most part. Okay, so let's try word count. Okay, so now here, we're going to stop, and we're going to go over to word count now. And we are going to totally go npm I first off. Then we're going to npm start, but it won't start. Oh, you know what? I can probably just leave it. And then this one, we're going to stop here. We're going to go to word count and go npm test. And so, like, that's not ready yet. But now when we edit here, let's go ahead and put the interface into the source file again. So we want the word count interface file in here so that I know how to start. And then we'll open that in the editor, right? And so now we're like, okay, so it's supposed to take a JS dict t and return an int, right? Or no, actually, a JS dict t int. Okay, yeah, that's fine. So we'll say that this is S. So then I'm going to say, whoops, const. Do we use const? I don't know. I'm going to say result equals this. I'm going to say we're going to get rid of that. Okay, so now let's look at loop. Functions. Let's take a look at loops. Okay, so we can just totally do this. So that's cool. That's cool. So let's... Oh, it says loops are discouraged in most cases. All right. Let's take a look at regex. What the heck is melange? What the backend for the OCaml compiler? Slurring my speech some more, my goodness. Melange strives to provide the best integration with both the OCaml and JavaScript ecosystems. Quite the intriguing objective. All right, so regex. Reason ML regular expressions. Okay, so we're gonna try this. We're gonna say S match. We're gonna put is that I don't usually do them like that. So if I have some word like the quick brown megalodon, match, so it's not that. I guess it's this. Oh yeah, that makes more sense. So now I'm writing it just like JavaScript, which is a little crazy, but like, I don't know, I'm getting the impression that like, maybe this should be reduced. I'm getting the impression that the syntax does have some similarities to JavaScript, perhaps more similarities to JavaScript than it does to F#. I don't know. Okay, so now what's it say over here? It says, found a bug, and it is illegal character line 2, 14 through 15. Okay, let's take a look. Right here. Okay, so that syntax is not gonna fly. So it does say something about using a regex. Okay, so type regex, compile a regular expression. Okay, so here's an example. So we did str.regex, and then we passed this in. Okay, so we're gonna try using that instead. In fact, let's copy this. Okay. So then it'll be B. No. We need parenthesis B, W plus B. Yeah? Where do we put a flag? Can we put a flag? The following constructs are recognized. Match word boundaries, quote special characters, grouping, alternate. So wait, so is the \W not recognized then because it's not on this list? Oh, that's crazy. Character set, grouping and naming of the What the? Okay, okay. Alright, so apparently we have to escape these. I guess it's fine. If the backslash W is missing, that seems weird. Um, okay, I guess I'll just do A through Z, A through Z. Get rid of these. But what about the flag? So nothing about the flag. What about global? Oh man. String match. Test. Search forward. Oh, I don't like this. Maybe it's fine. I hope it's fine. Okay, what about splitting? So I guess in reality, we're not going to use this and we're just going to split. Okay, now what's this say? Found a bug. Oh wait, scroll down. It says unclosed on line 1, column 20. This one's unclosed? So I don't... Interesting. So I don't think we can use reduce that way, right? So this should give a string list. Okay, so reason ml list reduce. Okay, fold. So we have to do array, fold left. All right. Okay, so we're going to go. Array, fold left. Something about this one is like really breaking my brain or something, right? Like I'm taking weird guesses as to what I think should be happening, and they are not correct. But we'll get there. Okay, so this is what I'm doing. Fold left. And then we put an initial. So that's going to be... Is there a comma? Yeah. So that's the initial, I think. And then it's S split. Okay, now what's this say? It says, found a bug. Isn't that what it just said? Opened line 1, column 20. Okay. So, yeah, it still thinks this is unclosed. Wait, do we need that? So we did array, fold left. Okay, so yeah, they did put a semicolon there. Now it says line 2, characters 4 through 9 unclosed. Okay, let's take a look. Is it this? Doesn't seem right. No, line 1, column 20. Okay, same thing. So we think this is unclosed. Let word count. Oh, this should be equal. What am I doing? Okay, so in. Okay, so we can't say that. We have to say dict something. Reason ml dict. JS dict? What about a map? Reason ML map. Module map? Okay, okay. Finite map or dictionary? Okay. So we can do empty, maybe? Oh, wait, why is it like this? Okay, make map. Oh my goodness. It's already pretty much time for me to stop, and I am making zero progress. Hmm. Something about Reason ML is rubbing me the wrong way. Okay, so so we can't do this. Records? Basic structures, list, okay. List, array, tuple, record. What about a map? Oh, here's a, no, that's a map over a list. Oh, man. Um. Okay, so this should be map empty, I believe. And then oh wow. Huh. Okay. So we can add exists. Okay, so map make okay. Well, this does seem like a good explanation. So let's see. We need a type and a compare. Yeah, what if we use this guy, JS dict? That's what they had in the first place anyway, right? So I don't know why this is rescript. I'm nervous. But sure. So we can do we have a JS dict empty? Okay, let's try. Okay. So we'll say get, no, JS dict get JS dict get, and we put in dict and word, and then we say not equal, and then we say none. Okay, let's see what that part says. Okay, it says syntax error, which is just says characters 8 through 9. Line 6, 24 through 25, it just says syntax error. Okay, this is at least more expressive. Okay, so I think we want to say set JS dict set dict word JS dict get dict word +1. JS dict set dict word 1. Has type option A, but somewhere wanted int. Okay. So I think there was another option. So if we get, it gives a sum, but was there an unsafe get? Okay. And we think we can unsafe get because we just checked, right? Okay. Has type unit, but somewhere wanted JS dict t int, and that is, okay, let's look at set again. Ages, yeah, so that seems like it should be okay. This has type unit, but somewhere, okay. Ah, okay, so when we set, it gives back unit, so we can't do that. We have to give back the dict itself, right? This has type unit. Oh, okay, so empty. But it has to be int, right? So maybe we don't want empty. Maybe we want something else. Record field split. Okay, so S is supposed to be a string. Reason ML function type annotation. Right? Okay, so if we put that this is a string, whoops. Record field split can't be found. Okay, so then reason ML string split. Okay, so it's in module str, I guess. And we want to go split. So we're supposed to put in regex string to string list. Okay. str split s. str can't be found. Trying to use the standard libraries str. If you're compiling to JavaScript, use js.re instead. Okay, let's try. Okay, so it's not there. Okay, I think it's JS string. Has type char. Okay, so now what's the test say? 9 failed. Yay! All right. So I got nothing. Oh my gosh. I think I reversed the split actually. Oh, something passed. Okay. So receive, let's see, with quotations. Okay. So we're using JS split. Okay. Where's the split here? So delimiter. Let's split by RE. Okay, so JS string split by RE. Then we did our RE like this, apparently, which looks wild to me. returns an array of the resulting substrings. Oh man, I want to be done so bad. Says a valid JS regex literal expected. Okay. Oh, gotcha. Array option. So yeah, so these gave sum everywhere. Okay. Closed. Line 7, 25 through 27. Okay, so if okay, 4 passed now. Expected. So they're supposed to be 2 lower, apparently. I've passed. Multiple spaces not detected as a word. So I did put something in there. Um, seven passed. Okay, so can't. So yeah, so apostrophe can't be it. So that's part of our regex. So I did so a single, so it could be any. Okay, so if it, gosh, let me go back. So if it's two or more, then it could just be that. But if it's just one, then it needs to not be an apostrophe, right? Okay, so now let me test out my regex. I've got to get going. Come on. Come on. Okay, so we're trying to split. You know, I like this original one better. If we're gonna, can't we use, can we use JS string match? Is that a possibility? Yeah, why not just use this? I'm not gonna get this done. Match. Okay, so we're gonna use this much simpler regular expression from here, right? Actually, to be honest, I'm not sure that's gonna work. Cheap viewers on streamboo.com. I've got to get this done. Oh. Reason ML is destroying me. Oh my goodness, why is it like this? I truthfully, I don't think it's supposed to be like this at all. I think this is pure skill issues. JS dict everywhere is wild. JS string everywhere is wild. Okay, let's see. So, wait, what did I do now? Unexpected token. Oh, match. Yeah, so that splits it anyway, so that's not even right. Did I do this one before? Oh. Reason ML is tearing me to shreds, baby. Okay, so it was split by RE, and we were using... Initially, it was just any non-word character, right? Found a bug. Okay, so then... Okay, so 7 passed. So they're just... So it's just if it's an apostrophe. Okay, so... We're trying to split by this, but not if it is a single apostrophe, right? Okay, so we're going to try split. So this is what we've got, right? So then it's going to be split by that, but only if it is 2 or more. No? So, yeah. All right, so then in the other case, it's going to be a single word character, but not an apostrophe. Okay, let's look this up. Okay, so this is something that I haven't really understood well with regexes. So we want character classes. So I think we have an in-depth guide, so we can negate okay, let's look at this one. Any word character where word character includes character. Okay, yeah, we can do this. So here we want to include not apostrophe A through Z, big A through big Z, 0 through 9, underscore, right? MDN trim. Okay, I think that could work. So we're gonna go. So this is gonna become star. Oh my gosh. Oh my gosh. I'm trying to type here. Star. All right. Not apostrophe. A through Z. Big A through big Z. 0 through 9. Underscore. Non-word character star. Okay. This is going to become... I don't know what I just did. This is going to become JS string replace we're going to put a regex. It's going to be G, no, it's not going to be G. It's going to be W plus at the end. Yeah, at the end. And then this one is going to become JS string replace regular expression, start of string, non-word character, plus unclosed at 18. Okay, let's see if we can do this any better. Okay, so what's unclosed, opened line 2, column 31. So it's supposed to match there. We're supposed to fold left. Okay, so I'm missing something. Okay, so replace. Reason ML JS string replace. Okay, JS string. It is getting so late. Replace by RE. Okay. So we're supposed to put regex replacement string. Okay. So replacement will be nothing. And replacement here will be nothing. Okay. Yes. Okay, so compiled and passed. Let's submit. Okay, let's see where it goes. Yeah, this is not convincing me that I ever want to try to use Reason ML for much of anything. Like, what is even happening, honestly? Okay, so no robot hint. Is there any possible, like, refactoring that I can think of? Okay, I gotta stop. It's about time for me to go to work. I'm probably gonna have to take my laundry out early. But I'll mark this as complete. I don't know, man. I don't know. I'm just very much not convinced that I would ever want to use Reason ML. It seems like there's a lot going on that seems pointless. I think that if I were to change the way I work quite a bit, and I would imagine tmux would help a lot. So I should probably start using that. It's really not necessary for most of these languages. All right, let's close down. Zero progress, like literally zero. I didn't finish anything this morning. Right? Like I started from the beginning. I was looking at, yeah, this same problem. I didn't even get to the actual problem, like nothing. So I'll come back on and try to get something done after work. It won't be Reason ML though. I'm gonna look at something different.